In episode 14 of the Junior PenTester training series, we are going to go through the concept of race conditions and how they actually apply to and affect web applications and web application security. This is actually a concept that is relatively new in the world of TryHackMe, and it is an important concept because it's something that can be exploited and manipulated for the benefits of the hacker. I'm not going to say necessarily that it's beneficial to the target or the victim, but I mean, we are talking about pen testing, so this is all supposed to be stuff that would be good for us as ethical hackers, as penetration testers. So we have the intro, what the concept of multi-threading, race conditions and what they are, web application architecture, because it's very important since we're manipulating and exploiting web applications. There's going to be the first exercise for exploiting race conditions, detection and mitigation, and of course the final challenge against the web application. This was developed by Strategos. I always mispronounce it. I have no idea what the correct pronunciation is, so that would be something that I'm actually curious about. In case you ever watch this, please drop a comment and let me know what your final pronunciation is for your username. This particular person has developed a lot of the rooms inside of TryHackMe, so we're grateful eternally to him or her or them or whoever it is for them to actually creating all of these resources for us so that we can learn and become better. This is a subscriber only room, which means you need a paid subscription to pull this off. TryHackMe is totally worth the money, so it's something that they actually require many universities for their students to get access to, because it gives you an environment for you to test all of these things and apply them and experiment with them without getting into trouble. So I do highly recommend it in case you have not checked it out. I get nothing from TryHackMe for saying this. I just really love the platform, and I'm grateful for them for having learned everything that I've learned so far from them. So very, very useful platform. I highly encourage it if you don't have one already. Let's talk about Hackaholics Anonymous for literally less than a minute, and then we'll jump into race conditions. If you're serious about your SysAdmin education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into race conditions. To help us really understand what these things are, let's look at a scenario. So let's say that you have the responsibility of testing the security of an online shopping web application. There are a lot of questions that come up. Can you reuse a single $10 gift card to pay for a $100 item? Can you apply the same discount to the shopping cart multiple times? The answer is actually maybe. If the system is susceptible, meaning if it's vulnerable to a race condition vulnerability, we can actually do this and then some. So in this video, we're going to be talking about what that specific vulnerability is, how in a situation in computer programs where the timing of events influence the behavior and outcome of a program, how this actually applies to that. It typically happens when a variable gets accessed and modified by multiple threads at the same time. And due to a lack of proper lock mechanisms and synchronization between the different threads, an attacker might be able to abuse the system and apply a discount code multiple times, for example, or make money transactions beyond their balance, for example. So the objectives of this video are to first understand what they actually are, what race conditions are. And using a tool like Burp Suite, one of our favorite tools in pen testing, there's multiple videos on this channel specifically on Burp Suite and how to use its different features. But we've also been using it a lot in this specific training series because we're talking about pen testing, and Burp Suite is literally designed to help for pen testing web applications. We're going to be using the repeater feature inside of Burp Suite to exploit race conditions. And along the way, we're going to learn about threads and multi-threading and state diagrams, the prerequisites for you to understand how the web works. So in case if you don't know how the internet works, that's a really good thing for you to study. You need to know what packets are, and you need to know what frames are. Now, these are conversations and specific elements of the OSI model, and they come for different parts of the OSI series, the OSI layers. So there are frames that go inside of packets, or packets that go inside of frames. I'm a little bit dyslexic. I forget which one is which. I think packets go inside of frames, if I'm not mistaken. And then, of course, there's the Burp Suite Basics, and you can actually find that video on this channel. And if you want, just go through the entire Burp Suite series of videos so you can really get a good understanding of what it is and what it does. And as long as you understand those things, you'll be able to pull off this room without any kind of a hitch. So let's get into the multi-threading concept. To understand multi-threading, we need to first understand programs, processes, and threads, and then how all of those things feed into this concept of multi-threading. So what is a program? It's a set of instructions to achieve a specific task, basically. You need to execute the program to accomplish what you want. So unless you execute it, it won't do anything. It just remains a set of static instructions, right? So you have to actually launch the program and use the program, interact with the program. There are different types of programs. They have different types of complexities and features and functions. And depending on the program, some of them require interaction to work, like a calculator, right? Even if you open a calculator, it's not going to do anything for you unless you actually punch in some numbers and use some formulas. So think of a program as a recipe. You just downloaded a new coffee recipe, and it includes a variety of herbs like cardamom and cinnamon. And these are the instructions, right? Combine brewed coffee, cardamom, cinnamon, and cloves if you're using it in a saucepan. Heat the mixture over low heat for 5 minutes, stirring occasionally. Don't boil it. Strain the coffee into your mug. Add milk if desired, and sweeten to taste with honey or sugar. Very interesting. I've never tried it. I don't even know if this is a real recipe. I am almost very curious to actually try it because I love coffee and I like messing around with coffee. So that might be interesting. I might try it. I don't know. And maybe it'll be horrible. So unless someone carries out the above instructions, no coffee will be served, right? You have the instructions, but unless you actually use them, nothing's going to happen. So comparing this to the minimal Flask Python, the Flask, which is in the Python language, and the very first program you ever learn pretty much in any coding language is how to print hello world onto the screen. Now, Flask actually allows you to create servers, right? So you can create a very basic server on Flask or through Flask, and that Flask, I guess that server will end up just printing hello world. So the code will dictate that the app will listen on port 8080 and respond with a minimal greeting that contains hello world. However, we must run these instructions before we expect to get any pages. So the Flask code is shown for demonstrative purposes. We didn't provide an environment to run it, so you can't actually run it. But this is just to demonstrate, right? From Flask, import Flask. That's always what Python scripts start at. You need to, like in 99% of the script, you need to import some kind of a library that you're going to end up using. Then you create a variable, which in this case is going to be the Flask pulling the name of the specific variable and instantiating the actual variable. And then we're going to route the traffic to this function, and it's going to just print hello world, or it says greeting hello world. That's basically all it says. Then it's going to check if the script is being run directly. If the name equals main, then run it on the host, which is the local host, on port 8080. And this is a very common function right here. It's looking for the name attribute, and if the name attribute is main, which is basically checking to see if this script is actually set up and running, and I don't know what I just did. I think I clicked around too much. And if it is, then you're going to run it. And now I need to put this back into my original window, so hold on a second. All right, there we go. So processes now. So we've talked about what a program is. So let's talk about processes. One afternoon, you decide to try out this new coffee recipe you downloaded online. You start going through the recipe one step at a time. You're in the process of making the coffee. While in the process of executing the instructions, you might get interrupted by an urgent call. The ice cream machine is in the background. The ice cream guy is in the background. So If it gets too loud, I'm just going to pause real quick until he leaves, but hopefully it won't be too annoying. You might work on another job, right? So if you get an urgent call, or you might be working on another job while waiting for the water to boil, which is what I actually do every single morning. I just start my coffee percolator and then I walk away, and when I smell coffee, I know that my coffee is done. The interruptions and waiting are generally unavoidable. The act of carrying out the recipe instructions who makes the coffee is similar to the process of executing program instructions. A process is a program in execution. Think about it like that. That's probably the best way to articulate this. A process that's running on your list of processes in your computer are essentially just a bunch of programs that are running, whether in the foreground or in the background. A process is basically a program that's running. It's in execution. So in some literature, you might come across the term job, and both of these refer to the same thing, although the term process has superseded the term job. But a job in this context is also the same thing as a process. So unlike a program, which is static, right? It's not running yet. A process is a dynamic entity. It holds several key aspects, including the program itself, which is the executable code, memory, which is the temporary data that's being used from your RAM. It's also known as volatile memory, and it uses the processing power of your computer. So if you have 16 gigabytes of RAM, when a program starts running, it's going to start using that processing power to execute. And if you have too many programs running at the same time and not enough memory to support all of them, then your computer is going to lag and it's going to crash, etc. A process usually hops between different states, and after it's in the new state, which is it was just created, it moves to the ready state, which means it's ready to run once given actual CPU time and CPU usage. Once the CPU allocates time for it, it goes to the running state. So it has 3 states, right? Furthermore, it can be in the waiting state, pending input or output, or even completion. So input or output would be something that a calculator, for example, would be waiting for, right? And once it exits, it moves to the terminated state. So technically, we actually have 5 states, right? So new means that it's been admitted, it's ready to go. Once it's ready, it needs to be scheduled for dispatch to get into running. If it stops running, it's interrupted, it goes back to the ready state. Once it's running, it can either be terminated or it can be in a wait state, which is awaiting input and output. And if it doesn't get that, then it goes back into readiness, or if it does get that, it will go back into readiness and then it'll start running. So it's a really great graphic that kind of explains the flow of a program's execution and what happens through its various states. And it's important for us to recognize this, because in different states there are different things that can happen to this specific program, and this is also where race conditions will end up coming in. We need to understand which state the program is actually in, or which state the process is in technically. And once we understand that, we can determine whether or not we can use a variety of different race conditions to manipulate the program or the process. So if we run that if we run that Flask code, a process is going to be created and it will listen for incoming connections on port 8080. Otherwise, it'll spend most of its time in the waiting state. When it receives an HTTP GET request, it will switch to the ready state, waiting for its turn to run based on the CPU scheduling. Once in the running state, it sends the HTML page to the client and returns to the waiting state. From the server's perspective, the app is servicing clients sequentially, and the client requests are processed one at a time. So just one after another, right, in order. And Flask is multi-threaded by default since version 1.0, and we use the argument without threads to force it to run in a single thread, which means it's forcing it to run sequentially, and it won't run multiple things at the same time. So the Flask command, again, is for demonstrative purposes only. So Flask run without threads, host, etc. It will then run, and it will run it in a single thread without having multiple threads, which will require it to run in sequence, right? Which then brings us to this concept of threads. So another coffee analogy, just wrapping it up. Consider the case of a commercial espresso machine in a coffee shop. Nice. Let's say it has 2 portafilters. At the start of the workday, the barista turns on the espresso machine, and whenever a customer orders an espresso, one portafilter is used to prepare an espresso shot for them. Does another customer order an espresso? No problem. The second portafilter comes in, and the warmed up espresso machine is the process. Each new order is assigned a portafilter, and that's the analogy for the thread, right? So you have a single thread. As you can see, the one on the left is technically a single thread espresso machine. This one is multi-threads, right? You can have two threads technically running at the same time. A thread is a lightweight unit of execution. It shares various memory parts and instructions with the process. So these two threads are technically using this overall machine or program, right? And technically, espresso machines actually do have programming inside of them, especially the modern ones. They're definitely programmed. So in many cases, we need to replicate the same process repeatedly. And think of a web server serving thousands of users the same page, or a personalized page, but they're still serving thousands of users. And we can adopt one of two main approaches. Number one would be the serial approach. One process is running. It serves one user after the other sequentially. New users are in-queued, meaning they're placed in a queue, and until the last one finishes, they won't be able to run, right? So that's the serial process approach for threads, right? The next one is parallel. One process is running, it creates a thread to serve every new user. New users are only in-queued after the maximum number of running threads is reached. So for example, you have two orders processing, two new people come in, they have to wait for these two orders to finish processing. Once they're done, they will get the next two spots. If these two orders are processing and four people come in and they order espressos, they'll have to wait in order. And so the next two will come in, and then the last two will get their turn once those are done, right? So threads still technically offer the concept of in-queuing or being in-queued, meaning placing somebody in waiting terms, right? And they just can process multiple things. So it's faster than a serial waiting time. Parallel waiting times will allow you to, or I should say, web server running these things, we can think of two approaches of this, which would be, I guess it is a serial or a parallel waiting time. So serial will be singular thread, parallel will be multiple threads, and then you're limited to the maximum number of threads. So the previous app can run with 4 threads using Gunicorn. I want to say Gunicorn. Man, these names. Who comes up with these names, bro? Okay, so it's green unicorn, so G unicorn, I guess, Gunicorn, whatever. It's a Python WSGI HTTP server. WSGI stands for Web Server Gateway Interface, which bridges web servers and Python web applications. So it just connects Python's applications to web servers. In particular, Gunicorn, Gunicorn, whatever, can spawn multiple worker processes to handle incoming requests simultaneously, meaning at the same time. By running Gunicorn with the workers for option, we are specifying that we want 4 workers, also known as 4 threads, to tackle client requests. Moreover, threads equals 2 indicates that each worker process can process 2 threads. So my bad. So each worker is not a thread. Each worker is an individual worker, and then each of these workers can have 2 threads, which gives us a total of what? 8 possible threads. So Gunicorn command, again, is for demonstrative purposes. We didn't provide an environment. You can't run it, etc., etc. So when you actually do run it like this, so Gunicorn workers 4, threads 2, it gives us 8 threads, right? 1, 2, 3, 4, 5, 6, 7. I'm guessing there's an 8th one somewhere working as well. So it's worth noting, it's impossible to run more than one copy of this process as it binds itself to port 8080, okay? TCP or UDP ports can only be tied to one process. So on port 8080, on TCP port 8080, as you can see right here, this process can only run on that specific port, which means that there's only going to be a maximum of 8 potential threads that can exist on this possible port. If you wanted to run it on another port, that's a whole other story. So you can't actually run Gunicorn on port 8081. and do the same thing, and now you have another 8, which would give you 16, right? So you can do that. It's just that in this particular example, it's running on port 8080, which means you're only allowed to have one instance of it. The process can be configured with any number of threads, and the HTTP request arriving at port 8080 will be sent to those different threads. So technically, you can actually max it out at, I don't know, 1,000. I can't say infinity, but because you actually do have to give it a number, but you could technically max it out at a much higher number, so long as your server can actually support it. That's the other part, right? Like the processing power of your server needs to be able to support it. So you downloaded an instruction booklet on how to make an origami crane. What would the instruction booklet resemble in computer terms? So it's still a program, right? We haven't done anything with the booklet. So it's technically a program. Now, what is the name of the state where a process is waiting for an IO event? And the key term right there is waiting. So the name of the state would be the waiting state. So now that we know all of this, let's talk about race conditions. All right, so here's a new scenario for us, a new analogy. Picture the following situation. You call a restaurant, you reserve a table for a crucial business lunch because you're very fancy and you're very professional. You're familiar with the restaurant and their setup. One particular number for table, the table number 17, is your favorite table, it's your lucky table. It's considering that it has a really nice view and it's relatively isolated and you can carry out business, right? You call to make a reservation for table 17. The host confirms that it's free as there is no reserved tag that's placed on it. At the same time, another customer is talking with another host and making a reservation for the same exact table. So at the same time that you're on the phone making your reservation, they're making their reservation. So who really reserved the table? That's considered a race condition. So why did this happen? This situation happened because more than one host was taking reservations. Furthermore, it took the host a few minutes to fetch the reserved tag and put it on the table after updating the daily reservation book. There is at least a 1-minute window for another client to reserve a reserved table. Similarly, when one thread checks a value to perform an action, another thread might change that value before the action actually takes place. So here's the first example. A bank account has $100 in it. Two threads try to withdraw money at the same time. Thread 1 checks the balance, sees 100, withdraws 45. Before thread 1 updates the balance, thread 2 also checks the balance incorrectly, sees 100 because the balance has not been updated, and withdraws 35. So that's a total of what? 80. Now, we can't be 100% certain which thread will get to update the remaining balance first. However, let's assume that it's thread 1. So thread 1 will set the remaining balance to 55. Afterwards, thread 2 might set the remaining balance to 65 if not appropriately handled, because thread 2 still thinks what? That there's $100 in the account. So technically, that's actually very interesting when you really think about it. Thread 2 calculated that 65 should remain because it's withdrawing 35 from 100, right? That's when thread 2 checked it. It was still at 100. So in other words, the user made 2 withdrawals, but the account balance was deducted only for the second one because thread 2 said so. That's pretty insane when you think about it. That's really awesome. Okay, so example B, let's consider another scenario. Bank account has $75. Two threads try to withdraw money at the same time. Thread 1 checks the balance, sees 75, withdraws 50. Before thread 1 updates the balance, thread 2 checks the balance, incorrectly sees 75, and withdraws 50. Okay? So thread 2 will proceed with the withdrawal, although no such transaction should have been declined. Or excuse me, the transaction should have been declined because technically, right, take out 50, you're left with 25. You can't take out another 50. It would overdraw the account. But these types of things would imply that thread 2 still hasn't seen the updated balance, or thread 1 is taking too long to update the balance. Therefore, thread 2 is operating based on the assumption that there's still $75 in the account, right? So, example, A and B demonstrate a time of check to time of use vulnerability. So this is a race condition vulnerability, what we've seen so far. So now here's a code, example code. So considering this specific thing with 2 threads running a task completion by 10% increments. So you import threading, x equals 0, which is going to be the shared variable, right? In this function, you're going to increase it by 10. So global is x, right? That's the global variable. And for I in range 1 through 11, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It won't go to 11. That's how Python works. It's going to increment x by 1, right? And then threading current thread, etc. Name 0% complete, right? And then it's going to add increment to it. And then it's just going to keep repeating this until it hits 10, okay? Thread 1 is threading.thread. So this is basically the thread function inside of threading. And it's saying that we're going to increase the target by 10. And for the target, it's literally calling on this specific function, as you can see right here. And then it's going to say, that's my name. And then for thread 2, it's going to increase it by 10. It's going to say, that's my name, right? Then we're going to start them. So thread 1 is going to start, thread 2 is going to start, thread 1 is going to join, thread 2 is going to join, and we're just waiting for them to finish. And then both of these things have finished completely. So this is basically a threading script, right? You're doing a script that's going to increment by 1 until it hits 10. It's a shared variable. So both of those threads are using the same exact variable, okay? So this is where everything kind of starts becoming a little bit interesting. So from the thread, from the current thread that it's using, whatever the name of the current thread is, it's going to take this integer that we have right here. And every single time that this runs, because this is going to, this for loop that's going to run right here, it's going to be a repetitive loop. It's iterative, right? It's going to iterate through this I integer variable. And every single time that it loops, it's going to increase. It's going to increment by 1 until it hits its final range. So it's going to start at 1, it's going to increment by 1 until it hits its final range, and it's just going to keep printing this onto the screen for us, okay? And that's basically it, right? So they start together, they do nothing except print a value onto the screen. Consequently, one would expect them to finish simultaneously, or at least the results to be consistent. However, in the program, there's no guarantee which thread will finish first and how early it will be. So this is the first execution of this specific script. So thread 1, 40%, thread 2, 70%, thread 1, 50%, thread 2, 80%, thread 1, 60, thread 1, 70, thread 2, 90, thread 2, 100, thread 1, 80, thread 1, 90, thread 1, 100, and now it's been incremented. But now you can see the variable is now in different, it's different. It's starting from the same thing. So let's actually see. I wonder if it starts at 10, right? Because it's not supposed to. It's supposed to just increment by 1 is what's really interesting about it, because it starts at 0. It's supposed to increment by 1, but it starts at 10 right here, and it's at 40% when it's at 10. And it's a global variable. It's a shared variable. So you would think, right, that they would be looking at the same value and only incrementing by 1 until they hit 10. So when you do a second execution, thread 1 starts at 70. It started at 40 this time around. Starts at 70, thread 2 is at 40. Thread 1's at 80, 50. So you can basically see that obviously they're not doing this at the same time. They're not finishing at the same time. Thread 1 is finished at 100% here. Thread 2 takes its sweet time. This one, thread 2 had finished. Now thread 1 was taking its sweet time. So running it multiple times will lead to different results. Each time it should lead to a different result, pretty much. In the first attempt, thread 2 reached 100 first. Second attempt, thread 2 reached 100 second. We have no control over the output. If the security of the application relies on one thread finishing before the other, then we need to set mechanisms in place to ensure proper protection. So considering those examples, it's better to understand the bug's gravity when we leave things to chance. So on the attack box, we're going to save this specific code, run it multiple times to observe the outcome. If you save it as race, you can run it by doing this. That's fine. So as we saw in the program, 2 threads were changing the same variable. Whenever the thread was given CPU time, it rushed to increase x by 1. Consequently, the two threads were racing to increment the same variable. This shows a straightforward example happening on a single host. Generally speaking, a common cause of race conditions lies in shared resources. So for example, when multiple threads concurrently access and modify the same shared data, examples of that are a database record and an in-memory data structure. There are many subtle cases. So these are 3. Parallel execution. Web servers may execute multiple requests in a parallel, as you already know what that means so far. So they basically run them at the same time to handle concurrent user interactions. If they access and modify shared resources or application states without proper synchronization, it can lead to race conditions and unexpected behavior. That's the parallel execution. There's database operations that happen at the same time. So concurrent, meaning running at the same time, those types of operations like read, modify, write sequences can introduce race conditions. So 2 users attempting to update the same record simultaneously may result in inconsistent data or conflicts. The solution lies in enforcing proper locking mechanisms and transaction isolation. Then we have third-party libraries and services. So a web app often integrates with third-party libraries, APIs, and other services. If these components are not designed to handle concurrent access properly, race conditions may occur when multiple requests or operations interact with them simultaneously. So that's kind of the 3 more common versions of when a race condition can take place, the causes of race conditions. So does the presented Python script guarantee which thread will reach 100% first? And the answer to that, of course, is going to be nay. All right, so in the second execution of the Python script, what is the name of the thread that reached 100%? And I think that was thread 1. So thread 1 was the one that reached 100% first. So we'll do thread 1. And that's pretty much it. So now let's look at web application architecture. I've done a good amount of conversations around architecture for operating systems specifically, but not necessarily architecture around web applications. I would imagine that there would be some similarities, but let's go through it and find out. There are multiple models that we can look at when it comes down to web applications. So there's the client-server model. When applications follow a client-server model, the client is the program or application that initiates the request. So for example, we browse a web page, the web browser requests the web page, which is a file, right? And so the client in this particular case would be the web browser. The server is the program or the system that provides that service and responds to incoming requests. So the web server responds to an incoming HTTP GET request and sends an HTML page or file to the requesting web browser, which is in this case what? The client, right? So that's the client-server model. Generally speaking, this runs over a network, meaning an internet connection. The client sends the request over the network, the server receives it and processes it before sending back to the required resource, okay? The typical web application follows a multi-tier structure. So architecture separates the application logic into different layers or tiers, and the most common designs use 3 tiers. You have the presentation tier, the application tier, and the data tier. So in web apps, the presentation tier consists of the web browser on the client side, meaning us, the users, viewing it and using it. The web browser renders the HTML, the styling sheets, the CSS, and any JavaScript code if applicable. Application tier contains the web application's business logic and functionality. So it receives client requests, it processes them, it interacts with the data tier, and it's implemented using the server-side programming languages like Node.js, PHP, SQL, possibly whatever, right? Data tier is responsible for storing and manipulating the application's data. So typical database operations include creating, updating, deleting, and searching existing records, and it's usually achieved using a database management system, DBMS. Examples of this include MySQL or PostgreSQL, and so these are the database management systems, but the actual programming language potentially would actually be the structured query language, which is SQL, right? So this would be the data tier, which is responsible for storing and manipulating the application data. So this is what it looks like. You have the web browser, which is the client, the users using the web browser. They connect through the cloud, the internet, to the web server. The web server will connect to the web application server, and then from there it'll be feedback to the web server, which will then feed back to the web browser, which will feed back to the actual user. So the states, right, we need to consider. You have a few examples. We have validating and conducting a money transfer. We have validating coupon codes and applying discounts. So for a money transfer, if you want to transfer, let's say, to a friend or to your own account, you're just doing an internal transfer, or you're doing a transfer from one bank that you have to another bank, like using Zelle or something like that, right? So this would all be considered a transfer. So you would click on confirm transfer. That's the last piece of the transfer. And then the application queries the database to confirm that the account balance can actually cover the transfer amount that you want. The database responds to the query. If the amount is within the account limits, the application conducts the transaction. If the amount is beyond the account limits, the application shows an error message. Not enough funds, right? Insufficient funds. So you click confirm transfer, application queries the database. Database responds to the query. If it's actually within the limits, it'll conduct the transaction. If it's not within the limits, it'll say insufficient funds. That's basically how it goes. In the ideal scenario, the code will lead to two program states, amount not sent or amount sent. So if the amount is not sent within limits, amount is sent. Amount not sent, it exceeds limits, and then it goes back to, okay, amount not sent, and it'll give the error message insufficient funds, so you have to change your amount. If it's within limits, it'll actually send it, right? So that's the transferring of the money. There's a validating coupon codes and applying discounts. So it could be another one. So the user goes to the shopping cart, adds a coupon code, and it could be they enter the code. Application queries the database to determine if that coupon code is actually valid and if there are any constraints. Then the database will respond, and it'll say it's applied if the code is actually valid and there are no constraints, or the message saying that if the code is invalid or there are constraints applying for that specific user. So they click apply, query the database responds, is it valid? No. Displays an error message. Yes. It applies the discount, right? So the two scenarios ideally in this case would be the coupon isn't applied. Is it valid? Okay, it's applied. It's not applied. Why is it not applied, right? It'll give us the error message to say it's not applied for whatever reason. Maybe you mistyped it or something like that. And it could be used, it could be not applicable to your user account. You could have another account that's already implementing that supersedes this one. There could be a variety of different reasons why it wouldn't work, right? So those two states may not necessarily be actually the case. So if we look at analyzing the discount code example, ideally you would want either not applied or applied, but it's too simplistic. So you can add a different state, an intermediary state, which means checking the availability of the coupon. So coupon not applied, right? You add the coupon, it checks the availability of the coupon. If the coupon is applicable, it'll apply the coupon. If the coupon is not applicable, the coupon will not be applied. So depending on how the application is developed, we can expect more states. So checking coupon availability could be checking coupon availability and checking coupon constraints, right? A coupon might be valid, but existing constraints on that user may prevent it from being applied. So coupon applied might also be divided into two states. It could be recalculating total. That could be another state. So coupon not applied, right? Add the coupon. It's checking the validity, and if it's invalid, it'll say coupon not applied. If it's valid, it'll say, okay, if there are constraints, coupon not applicable because of whatever constraint, so it'll go back to coupon not applied. If there are no constraints, then it'll say that the coupon is applicable, recalculate the total, and then mark the coupon as applied, and it'll say coupon was applied, right? So you can actually probably do this with almost every example that we've gone through, because there's all of these extra steps to check, right? Checks and balances is very similar in the digital world as it is pretty much in any other world. So Why is it important? Why is all of this important when we're talking about race conditions? Because all of these things technically take time. It happens in milliseconds or microseconds. It happens so quickly that you don't really get to see how long this actually takes. And maybe if your internet service is slower, it might take longer for you than somebody who's running a fast internet. But technically, each one of these steps takes a little bit of time, however long time it takes. And until it actually gets to this final stage, it's technically going through these variety of different stages, which means that something else could be running on a different thread at the same time, and they could, that next thing, that second thing could actually be running, and it could be doing something that maybe the web server or the web application doesn't want you to do. So in what we saw in the above example, there were passed through multiple states before the coupon is actually applied. So if we do it on a time axis, this is what it actually looks like, right? So coupon not applied, you add the coupon, checks the validity, checks the constraints, recalculates the total, marks coupon as applied, and applies the coupon. And this is the timeline, right? So from adding the coupon to the coupon being applied, there are technically 3 steps that are taking place, right? So this is very important to understand when we're talking about race conditions, right? It's literally a race. So there's a time window between the instant that we try to add the coupon and the instant where the coupon is actually marked as applied, and then it can't be applied again. So as long as the coupon is not marked as applied, most likely no control is prevented from being accepted repeatedly. And we might be able to apply it multiple times during this time. And this is where the burp suite repeater is actually a very interesting tool. So this situation is similar when considering the states for program making money transfer. So ideally speaking, it would be 2 states. Considering the business logic, we can easily update the diagram to include 3 states. The reason is that we expect some time spent checking the account balance and the limits. Although the amount of time might be brief, it's not 0, right? It's a very, very short amount of time, but it's definitely not 0 because it takes time. So if we dig deeper, we can uncover more hidden states. So again, amount not sent, right? You want to confirm the transfer. It's going to check the balance and the account limits. If it exceeds the limits, it's not sent. If it doesn't exceed the limits, if it's within the limits, the amount would be sent. If the web application is vulnerable, we still have one challenge to overcome, which is the what? The timing. So in vulnerable applications, the window of opportunity, that time between no, it's not applied, yes, it's applied. No, it's not sent, yes, it's sent. That's the window of the opportunity. So if we go back up here, right here, from here to here, this thing, this portion is our window of opportunity. So it's relatively short, therefore exploiting it necessitates that our request reach the server simultaneously. In practice, we aim to get our repeated requests to reach the server only milliseconds apart. So how do we get the duplicate requests to reach that? And that is what we use burp suite for. So how many states did the original state diagram of validating and conducting money transfers have? Technically, if we go up here, the money transfer one, this is the, what is it? Coupon not applied. If we go up here to the money transfer one, technically there were 2 states, right? So in the very, very first one, there were 2 states that were available for us. So as my keyboard just dies because I think I talk too much. So how many states did the updated diagram of validating and conducting money transfer have? And it had 3 states because we added that new state, right? How many states did the final state diagram of validating coupon codes have? And that was that big one that we had right here. So we have 5 states right here, right? So boom, and we go ahead and apply that. So now let's actually exploit the race condition. So let's have some fun. All right, for this particular exercise, there are a lot of instructions and click-by-click type of stuff that we have to do. So instead of just reading through this and then doing the actual exercise, I'm going to open the window, open the attack box and the burp suite and everything like that. And I'm just going to display it to you. And we're just going to go along with all of these instructions click by click. And hopefully I will actually be able to pull it off and we'll be able to get the flag at the very end of it. And if I can't, then what's going to happen is I'm going to troubleshoot until I do get the flag at the very end of it, because persistence is the name of the game when it comes down to this type of work. So we're going to open this up in a full screen so that you can actually see everything that's going on. and then I'm going to zoom back into here, and I'm going to move it into my second monitor, and then from there we're just going to truck along. We're going to make sure that we actually pull this off, and hopefully you will get the flag at the end of it. And I hope you're actually going along with me on this as well. Like the click by click, I think is very important for you to also experience as well. So let's open up Burp Suite and let's get the show on the road. All right, so here is Burp Suite. Now, usually when I use this, I do it in conjunction with Mozilla Firefox and Foxy Proxy so that I can intercept all of the requests that are being made from Firefox inside of Burp Suite. But based on the instructions that we have right now, they're telling us that they want us to use the actual browser inside of Burp Suite. So when you go under the Proxy tab, as you can see right here, inside of the Proxy tab, you get the option to open a browser, right? So you can click on that, and there's an actual, I think it's a Chromium browser that opens up inside of Burp Suite. But when you do this, so if you haven't configured it completely, when you click on it, it'll give you this error that it says you can't run the browser with sandboxing enabled. So your OS doesn't allow you to do it. So you have to go to Settings, Burp's Browser, and then allow it to run without a sandbox. So from here, what we're going to do, we're going to click on Settings, which can be accessible via this button right here. It can also be accessible up here through Proxy Settings. So we just do whatever, click on Settings, and then underneath that, we need to click on the Burp Browser, which is underneath Tools right here. So you can see that. Click on Burp Browser, you go through here, and then there's going to be a button. So I'm just going to zoom out to make it a little bit easier. When we have the Burp Browser, we're just going to go under, what is it? It says allow it to run using a, or without a sandbox or something. Oh, right here. Boom, it's right here. So allow the Burp Browser to run without a sandbox. So that's good. And we can just close this. And now we should be able to open the browser. And let's see if it actually works. So let me make sure I click it. So I did click it. So I wonder if it works. Let's kind of shrink that down. There you go. So now we have it. I think it actually opened up two. Yep, it did, because I double clicked. So there you go. We'll just close one. All right, so now we have our Chromium browser, and great. So we're using the no sandbox stability, all that good stuff. Okay, so we have the proxy running in the background. The browser is officially open. And now we can go to the web application port, or the IP address, excuse me. So it's basically this. So the one that was assigned when I launched my victim machine or my web app is on that IP at port 8080. Now the port 8080 part is not going to change for you, but when you run this, you're probably going to get a different IP address. So just keep that part in mind. So as soon as I clicked enter, I don't know if you noticed, but there was something that popped up in the background, right? And so this is what we see right here. So it says you can actually go into it and log in as any of the users, right? So that's kind of the key element that we're trying to see right here. So using this, we can see what we can find. We'll see that there's a GET request right here. I can click the forward GET request, and it should load the actual web page in the background, and it'll allow me to hopefully be able to connect to the, there you go. So there we got it. So I had to click the forward twice. So now I have username, I have password, and I think I have to do this multiple times until we get to the point where we want to get that post request. So I'm going to log in as this guy. So 77999, whoops, let's go back. So 0779999 1337 is going to be my username. Password is going to be pass1234. Press enter, and then again, we saw it in the background that there is actually a request that was submitted. So it's a post request now that we can see right here. So if I kind of pull this up a little bit so we can actually see everything. So we should be able to see the request as well as the response. So let's see here. Okay, so I logged in using the Chromium browser that it had, and I logged into one of the main accounts. So this is actually the Mozilla Firefox browser, I believe. So let's kind of shrink this one just so we can see both of them in the background here. So we have the second account. So this is the second account that I logged into, ends in 1111. And then we have the first one that I logged into that ends in 1337. Okay. So when you land on the home page, you get these two buttons right here. And so you click pay and recharge, and it brings you up right there, right? So if I just go back to home, this is the one that we're going to be sending money to. This is the Firefox, and then this is the Chromium, okay? So in this one, just to kind of show you how what we look like right here. So under the Intercept tab, I just clicked forward when I did the login on, like, I think maybe 2 or 3 or 4 times, and it completed my login, and I ended up inside the application. When you click on HTTP history, you can see all of the requests that were made. So there was a bunch of GET requests, right? So GET login, and then it retrieved all of these various elements for us. And then we were actually able to submit our login via the post request. This is where we were actually sending our login information in there. So you can see the username and the password. And then it redirected me to the dashboard that we see here. And then this was the response for that request, that post request. So this was the set cookie for the session, and this is the cookie that we got. Dashboard, connection, keep alive, and the timeout was 5. And so I want to say this is, for now, this is like pretty much the most relevant information. And we got to the dashboard, and we are now inside the dashboard, and all of that is working, right? So we're technically here. Now, the next piece that we want to do is we just want to kind of test to see if we send $1 or something like that, what would end up happening, right? We just want to try to transfer the amount, or an amount that exceeds the balance and a small amount, like $1, to see how the system will respond in each case. So I need to first get this number, which I guess is their mobile number, I would assume. So we would paste the mobile number in here. We would paste the other same thing, paste it over here. And then first we want to send $1. So we'll just do $1 like that. And then we'll transfer it. And then we'll get something in the background in Burp Suite. So you can see there's a post request that's taking place. Target phone number is that phone number, confirm phone number, and amount is $1. And so that's what we got right here. I'm going to forward it, and it's done. So we'll go to the HTTP requests. We'll look at this request right here, that post request to send $1. And then we can see again the data that was submitted. So target phone number, confirm number, amount $1. And it says keep alive, timeout 5, dashboard transaction successful is where we were redirected, and remix status 302, I guess, and all of that. And so on the request side, we can see that the content length, let me see if there's anything that's relevant to the actual time that's taking for this to process, because it doesn't seem to really give me much on the number of seconds or something that it took really to get there. Let's see what we can see over here. Status code length, extension, title, notes, IP cookies. It gives me an actual time value, which is over here, but it doesn't really tell me anything else. So let's kind of shrink this down, see if we can see anything else. And let's see. Yeah, so it doesn't really give me anything about the length of time that it took, at least on the surface level. I'm pretty sure I could try to find something if I kept digging into it. The page on the Chromium still says transferring right here. This guy still has his old balance. So if I maybe refresh the screen, okay, we see that we got the $1 transferred to this person. So $8.98. So they actually did receive the money sent to them. If I click on home, I wonder if this will load for me without doing a whole other thing in the intercept. It doesn't. So we need to forward these things so that we can actually get to our home page. So let's make sure we actually get there. All right, so now we're in the home page. Our dollar balance here is $4.55, and the HTTP history reflects all of those GET requests because I clicked on home multiple times, blah, 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 blah. Okay, so we were able to send $1 successfully. Now what we're going to do is we're going to send $10, right? So we're going to do the same thing. We're going to send it to that phone number. And what we want to do is we want to send $10 this time, which is going to be more than our limit. It's more than what we have available. So we're going to go back to Burp Suite. We're going to click on Intercept. We're going to forward this post request, and let's make sure that it actually gets there. So I'll forward it one more time, An application error. Interesting. So no user found in root loaded, but the user is required, etc. So the application gave us an error. So let's look at what happens over here with the request that we submitted. So this is the post request that had the $10 request, right? So that's the one. So we submitted that. The response after the fact gave us an insufficient balance data root response, and that was the session cookie that was assigned to it. And then we got another one that gave us a 200 response code, which was a success message. So the actual response itself came back fine, it seems, because it was a 200 response code. But the value of this, the message transaction declined, so that was the response that we got, and we got a good amount of data from this as well. Unexpected error occurred, note not found, unexpected error code, unknown error, etc., etc. So transaction declined is what we see inside of the URL at the top, and the message itself is insufficient balance. So that's kind of the key things that we can take away. So all right, so that makes sense, right? So we got that. The credit itself did not work because the balance was $4.54, and it should still be a week. But the thing is, this specific thing, it says that it gave us a successful reload of the web page when it actually didn't. So I'm just going to go back to the home page manually, and let's see if we can actually get into it by just forwarding that GET request and get ourselves back to the home page. Okay, so 455. And obviously transaction was declined. We were not able to transfer that money. So now what we're going to do is we're going to use the Burp Suite repeater, right? So we can try to manipulate this whole thing and see what we can actually get done, right? All right, in order for us to get that final flag for this exercise, we need to get either of these accounts to basically have more than $100 in it. So since this one has 455, I'm essentially just going to duplicate this $4 by what? By 20? No, that would be $80. So let's say by 30, right? We'll do 4 times 30 repetitions, okay? And that's the whole idea here. So the first thing that we need to do is we need to redo another request, and we need to submit it as a repeater request. So we need to first do a post request, and we need to send the $4. So we'll do this, we'll do this, we'll send $4, right? And then we're going to click transfer. Now it's going to be captured by Burp Suite, and we'll see it as a post right here. So what happens is that this post request is going to be created. I should see it on my list right here. This is what we have right here. So there we go. We have $4 submitted over here, target phone number, and then we have a $4 amount. So this request is the one that we're going to repeat because we want to make sure that we actually get $100 inside of our target account. So what we're going to do is we're going to send it to the repeater. You can also do Control R. And when you do that, your repeater highlights. So we click on repeater, and now we are here. So the next step that we need to do is we need to duplicate this, right? So when we send this to the repeater, right next to the received request tab, there's a little plus button, right? So let's go ahead and do that real quick. So this is the actual tab right here. So this is the number 1. So we're going to click on this thing right here, and we're going to create a tab group, and then this will pop up. And you just got to make sure that you need to add this one, which is going to include our tab right here, which is that post request that has the $4, and we're going to create the group now. So now we have a group here, okay? Once the request tab, which is this number 1, has actually been assigned to the group, which we just see right here, we can right click on this, and there you go. So there's the duplicate tab button. Now this is gonna pop up, and it's gonna allow us to do it ideally. So I'm gonna duplicate this thing 30 times because I'm interested in sending, and look at that. You see all of these things right here, right? So now we have these duplicated tabs that we can hopefully, ideally, go ahead and repeat. So what we can do now is we can click on send, right? So let's make sure we're actually on the group itself. And we can, once we click on the group, it has all the 31 duplicates in there. We can click on send, and it'll say send current tab. send the group in a sequence as a single connection, send the group in sequence as separate connections, and you can also send it in parallel. Now, based on everything that we've discussed so far, sending it in sequence most likely isn't going to work, and there is documentation, everything inside of the lecture portion of this that tells us that it's not going to work. So I know for a fact, and just to make sure that it does work in the interest of time, we're going to send it in parallel, because that's literally what we want. We want to send everything at the same time to actually be able to pull this off. And that's what the documentation tells us to do ultimately, because if we send it in sequence, either as a single or a separate connection, we are going to get failed responses. We're going to get failed requests, I should say, that are going to send it out. But if we send it as a parallel, if we send the group in a parallel, it will send everything all in one at the same time, and the processing time will be much smaller. When you send them in sequence, the processing time is typically half a millisecond. When you send it in sequence, it's about 3 seconds per request. When you send them as parallel, it's about half a millisecond per request. So it ends up being much, much faster. And all of them should be successful in this particular case. So what we're going to do is we're going to send all of these things in parallel, and we're going to just click it, and let's wait for it to complete. And it's completed. We actually got a response. It's at 204, which I think is in the series of successful responses. So we did have that. And if we actually go to the proxy, we should be able to see, I think, in the history of these things, or we'll go look at the documentation. But I do know that it actually has completed because we got that final response from our repeater in this particular case. And if we go over here, there you go. I already refreshed the page, but you can just click refresh if you don't see the balance updating. And now we can see the balance is updated to over $132. And now we actually have our flag to complete this specific thing, which is THM phone race. So why was this successful, right? This is the point of the documentation that we're going to end up having to do right here. So first, let's make sure that we get our flag, because that's a key element that we want here. So phone race, there we go. And so that's our flag. So let's go read through the documentation to see why this actually worked, right? So the instructions is basically what I just did. So we used the repeater, we sent the post request, it was captured. We forwarded the post request to the repeater. We created a group for it, right? So this is what they did, create the tab group. We added our initial tab to it. We duplicated it. They just duplicated it 20 times. I duplicated it 30 because I wanted to make sure that we actually crossed that $100 line. I could have probably done 25 and it would have still gone to $108 and we should have still been fine. But what we're doing is we're essentially, the key element here is once you've done the duplication, you need to send them in one of 3 different formats. You see in sequence, single connection, sequence, separate connections, or parallel, right? So if you do sequence in single connection or separate connection, on a single connection, it sent all the requests in tabs before closing the connection, and it can be useful for testing client-side desync vulnerabilities. When you send it over separate connections, it sends a request from the group, closes the TCP connection before repeating the process for the subsequent request. So when you do this, the screenshot shows 21 TCP connections because that's what they did on their end for this exercise. And the first group that was labeled 1 comprises of five successful requests, and they were successful by checking their respective responses. We can also see that they took around 3 seconds as indicated by the label 3 right here. So if we kind of zoom in on this a little bit, this is the first group. The section at the top, they were actually successful, and we can go to the responses to see whether or not they were successful. Where are the associated responses? I don't see the responses on this particular screen, but these were the ones that they said were successful, so we'll take their word on it. And then we can see that the duration on the right-hand side here took 3 seconds on average, right? So it took at least 3 seconds to complete those. The next ones, the section 2 right here, these were the unsuccessful responses that came back, and these ones took a significantly less amount of time, right? So the second group, label 2, shows 16 denied requests. They were around 4 milliseconds. Interesting to check the relative start time as well, right? So that's basically what we have for this grouped version that was sent in separate connections, the sequence over separate connections. We can also see the whole TCP connection for a single request, and we can confirm that the post request was sent in a single packet. So that's very important to understand. It was sent in one packet. You can see it right here in this one line item. There were 21 requests that were sent inside of that one packet, but it was sent in one packet. But what happens in the parallel portion? So this is what we did and actually got the results, right? In the start column, we notice that there are 21 packets that were sent within a window of 5 milliseconds, right? Labeled as 1, as we can see right here. So all of them were sent within 5 milliseconds. So 216826 was the start one, 217371, so literally 5 milliseconds was the length of time that all of them took to send, not just one at a time. Each packet for the first example was taking 3 seconds each. All of the 21 that they sent over here were sent literally within 5 milliseconds. All of them were also successful, and they resulted in a successful credit transfer. And each request took about 3.2 seconds to complete, which was this portion right here. So the packets were sent in 5 milliseconds, but each one of them took approximately 3.2 seconds to complete. Okay, so this is what we got. Now, when you pay attention to it, you notice that each request led to 12 packets, which is what we see in this packet line right here. However, in the previous attempt to send in sequence, we see that each one of them had 10 packets. So why did that happen? According to sending the groups in HTTP requests documentation, when sending in parallel, the repeater implements different techniques to synchronize the request's arrival at the target. They arrive within a short time frame. The synchronization technique depends on the HTTP protocol that's being used. In HTTP 2 or above, the repeater tries to send the whole group in a single packet. In other words, a single TCP packet could carry multiple requests. In HTTP 1, the repeater resorts to the last byte synchronization, which is achieved by withholding the last byte from each request, so it's not sent incomplete, or it's not sent completely, I should say. Only once all of the packets are sent without the last byte are the last bytes of all of those requests sent. So it's very interesting. You can send up to 100. They will be sent all the way up to the last byte, but the last byte won't be sent. And then once all of them are sent, then all of those last bytes are sent. And so you can see that the post request was sent over 2 packets in this particular case. You have the TCP that was sent, and this is a Wireshark analysis that we're looking at here. And then we have the HTTP that was sent, and it was sent over a span of like a fraction of time. So it wasn't really that long of a time, but it was done in multiple packets that was sent. And inside of those, you had these individual bytes. So this is, it's beyond the scope of this conversation because we would have to dig deeper into packet analysis and Wireshark and networking in general and all of those things. But if you ran the exercise the way I ran the exercise, you should have received the flag that I received. And I don't want you to just get the flag just so you can get the answer. I want you to go ahead and actually run the exercise and do the repeater, create the group, create the duplicates, and send them as a parallel group just so you can actually get this response, because it is quite interesting and it's quite fun when you run something like this and it actually ends up working. So now we can move on to detection and mitigation. Detecting these types of conditions from the business owner's perspective is challenging. If a few users redeem the same gift card multiple times, it would most likely go unnoticed unless the logs are actively checked for certain types of behaviors. And these can be used to exploit even more subtle vulnerabilities. So it's clear that we need the help of a pen tester and bug bounty hunters to try to discover these types of vulnerabilities. So pen testers understand how the system behaves under normal conditions when enforced controls are actually enforced. The controls can be use once, vote once, rate once, limit to balance, limit to 1 every 5 minutes, and a bunch of other types of controls you can implement. And the next step would be to try to circumvent this limit by exploiting the actual race conditions. So figuring out the different system states that can help us make educated guesses about the windows where a race condition can be exploited. And this is where Burp Suite can be a really useful, handy tool. The mitigation can be done in a few different techniques. So you have the synchronization mechanism, which can be done by programming languages that provide these things like locks, right? So only one thread can acquire the lock at a time, preventing others from accessing the shared resource until that lock is released. Atomic operations refer to invisible execution units, which is a set of instructions grouped together and executed without interruption. This approach guarantees that an operation can finish without being interrupted by another thread. And the database transaction, which are multiple database operations that go into one unit, right? So consequently, all of these operations with the same transaction either succeed or fail as a group. And this approach ensures that data consistency that prevents race conditions from multiple processes modifying the database concurrently. So these are potential mitigations that you can deploy, detections that can be done. And again, this is beyond the scope of what you're doing, right? This is not something as a junior pen tester you're going to be responsible to do. This is the job of the senior pen testers, the job of the security engineers and the developers and all of the people that are going to be working on this. It's just that you need to understand these things. So I don't want to hear any comments of, hey, how do I do this and what do I need to do? Like, this is not your job. This is just so that you're aware of what's going on, right? Your job as a pen tester, or I should say as a junior pen tester, your job is to understand that these are the things that can actually take place and that they need to be accounted for, and they can cause a lot of damage and a lot of money and all of those things to a given business. So you need to work with the senior pen testers as well as the security engineering team to make sure that these types of race condition vulnerabilities are mitigated. So let's go look at this final challenge that we have. For this challenge, we're basically left to our own vices, and the goal is to transfer money so that we can get past a certain limit on an account, and then they'll release the flag to us. So we've learned about race conditions and various situations leading to them. System complexity, geographical spread can lead to unforeseen situations, including vulnerabilities for race conditions. So it's vital that we first observe how the system behaves under normal conditions and then try to find out how it behaves when we try to exploit the timing. With the currently available tools, we have plenty of available techniques to try. I pretty much know exactly what I'm going to try, which is going to be exactly the repeater exercise that we just did through Burp Suite. And for the most part, it should be successful. So we have the machine that's right here. I had to cancel this machine, the previous machine, and then start this one. So hopefully it's available in the background. Sorry about the noise that my freaking annoying neighbor's kids with their stupid bikes. I really want to go ahead and destroy their bikes because they're just loud for no reason. Excuse my anger. I just got really annoyed real quick because I'm almost done with this recording, and then these guys decide to go right now at 8:35 and just start driving around on their stinking anyways, dude. Moving on. All right, excuse the anger. All right, so this is going to be the new IP address at that port. That'll probably be our banking application. We have 3 users that we can see we can transfer money back and forth from. And let's log into them to see what their balances are. Okay, so the first guy, Razor Kond, has $100 in his account. And he has favorite transfers already that are here as well. So let's see if we can log out and go check out what the balance of the other guy is. So we have 6282 and White Horse is his password. He also has $100, and so we can log out. I'm pretty sure they're all gonna have $100. So it's like, okay, well, what's the point here? So if we do, 9317 as the last guy, green, orange, and he has also $100. So, okay, so, that's pretty much it. So we're going to transfer the money into this guy's account, which is Warunki, I guess. And then we will go over here. We'll go to proxy. I'm going to clear all of the history of everything that's here, just so we can kind of start fresh here. So let's remove from scope. And what's going on? Let me delete these items real quick. Delete all these selected items. Yes, I am sure. And we should be starting fresh. We're going to go to intercept. We're going to drop this connection, which is that final connection. We're going to open our browser. And I did it again twice because I'm just click happy. And so we're going to now go to the web application itself, which is stored at 10.10.104.68 on port 5000. It's going to give me the request to actually process it. So let's go ahead and forward it so that we can log in. And this is what we got. So we'll start with this guy. So 6282 White Horse, and his request to log in should be submitted to Burp Suite. So we're going to forward it so that we can actually log in. There we go. No response received from the web server, of course. That's so annoying. Okay, so let's do that one more time. Let's see if we're actually logged in, because I should already be logged in. I don't know why it's saying that I have no response received. There we go. Okay, cool. So we're officially here, and now we want to do transfer to Warunki is what we're trying to transfer to. So we'll click on favorite transfers being Warunki, and then we're going to go back into Burp Suite, and we're going to forward it. And you could technically turn off intercept to be able to pull that off so that you don't have to keep doing forward and going back and forth. So you should be fine in that regard. So this is the key element right here, right? So the piece that we want to get to Warunki is going to be, let's say we're going to do $99 of a transfer. If you send 99, it sends him $4.95, and he's going to end up getting $94.05. So that's what the fee is for that. So if I send 99, he actually ends up getting 94.05. And if I just repeat that 10 times, then he will end up being over, because he'll get $940 and he'll end up being over 1,000, right? And then that should be the goal, right? It says after the account gets 1,000, we'll be fine. So we're going to click continue on this. Burp Suite is going to capture it, and we now have the request. We'll go to HTTP history. We have the transfer at the bottom right here, and the data that is being sent is 99, and he's going to end up receiving 94.05. So this is the one that we want to duplicate. So we're going to right click on that. We're going to send it to the repeater. The repeater is going to highlight. Then we're going to, I just want to delete this group. So let me delete this group. Close all tabs in group. Yes, close all of those tabs. And this should be the request that I'm making right here, which is, yeah, this is the one that I'm making. So now I'm going to create a group, and we'll call it group 2. We're going to include tab 32 in there. And there we go. And now we're going to right click on this. We're going to duplicate this. We don't need to duplicate it 30 times, although that would be interesting. We'll duplicate it 10 times, which will give us a total of $940 that will be sent to Homeboy. We're going to click this drop down. We're going to do parallel. We're going to send it in parallel and cross our fingers. Okay, so the response came back with a 200 status. It was completed. Let's go and check his guy's account. We'll do a quick refresh. And does he have $1,000? He doesn't. He does not have $1,000. So let's see why. I wonder what happened. So it sent $476. And that's actually interesting. And the only way that I was able to actually find that out was logging out and logging back in, because refreshing didn't work. So that was interesting. I thought that it would send more money, but I guess we have to now repeat this another time. So we're going to log out of this guy's account. Let me actually turn off intercept and log out of this guy's account. We'll log into Warunki, and he's going to be the one that we're going to end up using as the final passage here. So we'll do green, orange here, log in. So he has 476. That's fine. We'll go back here and we will turn, or let me actually click transfer to, who's this guy? So we want to send it to, we want to send 476, and we're going to send it to Rasser. So I'll send it to RasserCont. So we're going to log out of that guy's account. We'll log into Rasser. So 4621 will be the guy that we're going to be receiving the final money. So technically, I guess it repeated what, like, I think it repeated 3 times or maybe 4 times, because it went from 100 to 476. So he gave him 376, which is 4 times. So that was the 4 repetitions that I think it actually was able to complete for us. So if that's the case, we can now just repeat this, let's say 3 times, right? Just to keep within those confines, and it should be fine. So we're going to send the money to Rasser. and I'll click that. And now before submitting this, I need to turn the intercept back on. So intercept is now on, the proxy is running, and we're going to send $470, which will do 446 finally. And then if we just repeat that 3 times, it should be fine. So we received the request. We intercepted this right here. We're going to go to HTTP history. We'll go at the bottom. We have this request right here that's sending the 470, which ends up 466. Okay, perfect. Right click on this, send it to repeater, go to repeater. Now we have this guy right here. So we're going to do this. We're going to actually, no, I'm sorry. We're going to click this button right here. We're going to create a group, which will end up being group 3, include number 43 in there. And now we're going to right click on 43. We're going to duplicate it inside that group. And we just need to duplicate it 3 times. That's all we need. So we'll do that duplication, crash that, and then make sure we're clicked on this right here. And just to make sure that we're on the right one, it is 470, perfect. So now we're going to send this in parallel, and then we're gonna click on that and wait for the response, which should be a few seconds. There we go. And it says internal server error. And the server encountered an internal error, was unable to complete the request. Either the server is overloaded or there's an error in the application. Very interesting. So I hope I was in the right one here. So let's try it one more time. Let's see if it gives us an, okay, there we go. The second time it worked. And so let's see if we actually get this guy's funds. So we'll log out of RazerCond, and then we will do the 4621 login one more time. Let's see if it actually works. And he only has 546. So this is really interesting that this is actually not working the way that I thought it would. It's not sending all of the money. And I guess now we have to repeat this twice or something. Like, this is so odd that this is happening. So, okay. So this is fine. Let's go back to Burp Suite, and we will go to proxy. We will turn off intercept just so we can navigate appropriately. Transaction failed. See, that's the issue right here. So let's go to this, and he still has $476 though. How crazy is that? The transaction failed, but this guy still received $476 or whatever. What is it? 446. He received $446. That's so crazy that it failed. Okay. Anyways, all right, moving on. So we're gonna try it one more time because he still has $476. This is insane. So, okay, so he still has $476. Burp Suite Community Edition error. Of course, there's an error. Please get back to my dashboard. Thank you so much. Let's go here. Let's turn the intercept back on. We are going to try this yet again. Before I do that, I'm going to go to repeater. I'm going to just close these groups right here. I just want to close all the tabs in this group. Yes. And we're going to go to group 2. We're also going to close all the tabs in that group. Yes. And then we're going to go to proxy, HTTP history. We're going to select all of these items. We're going to delete all of these items, and that'll be good. So that we're starting fresh, right? WebSocket, all of that stuff, we're going to start fresh. Where intercept is on. Actually, let's just get to the transfer page. So we're sending it to RazerCond, and let's make sure he still has 546. He does. So we're sending it to RazerCond. There we go. We're going to go here, turn intercept back on, and let's do this one more time. So I need to just send him not even that much. I just need to send him, we'll do 400 to keep it light. So $380. We just need to repeat that twice, and it should be fine. So we're going to do continue. It should be captured in the back end. Perfect. So let's now go inside of this, go to HTTP history, click on our post request. We see the request. That's exactly the one that we want. We're going to forward this to the repeater. The repeater is going to be here. We're going to create a group, and we're going to add it to the group. Perfect. And now we're just going to duplicate this once, I think. Oh, I don't even need to do that because it was duplicating it, because it includes the first one as well. So if I duplicate it just once, it'll just have 2 groups. Maybe that was the issue that was happening, because when I duplicate 3 times, it includes the first one, so it ends up being 4. Maybe that ends up being the issue. No clue. So we have these now. We have 2 different requests that are inside of this group, and we're going to send them in parallel. We're going to send group into parallel, wait for the response. We got a 200 response. That's all good. So let's go and look at this guy's account and let's see if we got it. And seems to not be the case. So let's log out. Let's go back into Razor's account, which is what, 4621. Log in. Still has not been sent. So let's do one more time. The result seems to be false, which is interesting. I wonder why this is happening. And Warunki still has the 476. So this is what's happening. I feel like the second time that the error processed, it actually really didn't send any kind of transit, because it did give me an transfer error when I lifted the intercept. So then what we're going to do, I guess we're going to log out of Warunki. We're going to log in as RazorCon, and then we're going to transfer out of RazorCon's account and see if we can pull this off. Hopefully this will work, because this is, now I'm kind of upset that this is not working. So let's go, and what was Warunki's login? It's the 9317 is his login. But see that it worked for this. So maybe, what is it? Is it Zavodny? Is the one that has the money, 6282? No, he only has $1. What the hell? That's so insane. I don't understand why this is not working, because technically that's so frustrating, dude. Okay, so fine. Let's go and log back out. I'm just moving money around at this point, and it seems to not be working, and it's so annoying. Okay, so the transfer did work for this guy because the money is now gone. So this is what's really obnoxious now. Okay, so we want to go back into Warunki, and we're coming from RazorCon. So we're going to send him a total of $500 twice. That's basically what I'm trying to do here. And I am sincerely hoping that this is going to work. Actually, so $500 will end up being $475. So we'll do it 3 times. So we're going to duplicate the request twice. If this doesn't work, I'm just going to be so upset, dude, because this should be working perfectly fine. So there it is. I'm going to do that. We're going to send it to the repeater. There's some kind of challenge that I seem to be having for whatever reason, and it's kind of upsetting me. No, it's not upsetting me, but you know what I'm saying. It's like, it's frustrating. It's like, why is this happening? I don't understand why this is happening. And I'm doing everything the way that I should have done it, or the way that we did do it previously. And it did work in some capacities, just for whatever reason, the other pieces of it aren't working, and it's really kind of upsetting me. So I keep saying that, but it's really not. So duplicating it twice will end up giving us 3 of these tabs. That's great. We're going to make sure that we have the group selected. We are going to make sure that this is being sent in parallel, and it's going to send the group in parallel, and click. It's going to give me a response, and it gave me an internal server error. The server encountered an error. Oh man. And now the second time it worked, and it said the result is false, but it said it worked. So let's see what's going on here. The Warunki account still has $6.20 in it. All right, we're back in day 2 of this exercise. I did some Googling, and other people also ran across pretty much similar challenges to what I ran across. And there were a couple of items that, or comments that said people had to try this multiple times to try to make it work. So I don't feel as bad about it not working yesterday. I'm hoping to be able to approach this with a fresh mind and hopefully be able to actually make it work. This time around, I'm just going to use the Firefox browser with the Foxy Proxy extension. And so this is the extension that's available as an installation. There's a good series of tutorials that I put for Burp Suite that you can use to learn how to configure Foxy Proxy. But if you actually are using the attack box from TryHackMe, it comes pre-configured, and all you have to do is just turn it on the way that I did. You would go click on it right there, and then just make sure you click on Burp, and then it's actually turned on, and your browser will end up working. And then as long as Intercept is turned on over here, it'll start capturing those requests. So we are inside of Razer Khan's account, and from here we're going to send money to Zavodny, and from here we'll do $95 or whatever, $95, which will end up doing $90.25 in total. And from here we're going to turn on intercept, and then I'm going to click continue, and the capture will be made. So the request is going to be captured in the background, and we're going to right click on this. We're going to send it to the repeater, and inside the repeater we are going to create our first duplication here. So we'll do a tab here. I'll make this the first one, and we'll start it with a red color, and we'll do a duplication of, let's see, I just wanted to see if it'll actually work properly. So if I do 2 duplications, it'll give me a total of 3 requests. So we'll start small, right? And then we'll go here, send it in parallel, and we're going to click send. And let's see if the server will respond appropriately. It gave us a appropriate response. So 200, okay, we sent 3 requests of, what is it? $90.25, right? So let's see how much ends up in the Zavodny account. So from here, I'm going to go to proxy. I'm going to turn off intercept, and the request should have been completed. So if we go to log out, and we'll disable burp suite, go to log out, and it should log us out, and we'll go to Zavodny's account to see if money was actually transferred into his account. That would be great if it was. And so $90, so there was 1 request that was transferred into his account, which is, I guess, okay, because it should have transferred more, honestly, because it seems to have only transferred just 1 of the requests, and I thought it would definitely send more. For whatever reason, I thought it would send more, but it only sent that 1. So we will intercept back on. So we're going to send to Varunki's account this time around, and we'll do intercept on. We'll make sure to turn on burp suite up here, and we're going to see if we can send that 190, which will be 180 final, and go over here. I'm gonna forward the request, or let's send it to a repeater first. Go to repeater, and we're just duplicating, or we're repeating the cycle just to see we can actually pull this off. Hopefully, I'm at this point I'm just trying to see what the potential limitations may be, how I can maybe do this more. Not exactly sure. It should be possible. So now I'm going to do 20 requests, which will give me a total of 21 tabs. And we're going to send them in parallel. I'm pretty sure it's going to make the server crash, but let's see what it will actually do. It gave us a true response, so the server did not crash. So let's actually go and see whether or not this actually works. I'm going to give it like a few extra seconds before I end the intercept to see how much of this actually works, because the request that I had, this transfer request, was the one that we just modified. And this is the one that has 180, and so I hope that that's the one. Yeah, that's the one with 180. That's the one we sent through the repeater. So let's turn intercept off. It's going to say transaction failed, obviously. We will turn the Foxy proxy off. We'll go here, and we're going to try to log into Varunki's account, because that's the guy that we sent money to. Oh, wow, that worked. Holy cow. I can't believe it. Okay, I'm actually shocked that that worked. So I'm gonna take my win. Because that was it was like one of those like stressful situations. So this time around, it actually worked in 2 requests. I have done this multiple times since last night, and it did not work this quickly this time. So I would say duplicate what I just did if you want to make it work. And for a second, I was afraid that I wasn't recording. And I was like, God, I hope I captured this recording, but I actually am recording. So that's nice. So based on the stuff that I read when I was doing my research last night, and just the experiences of other users, there was no official, here's what you should do and here's what you should try and you'll get this to work. People just said that they had to try it multiple times. And then I tried this myself prior to recording. I tried this several times with a variety of different strategies, and the most recent one right before this recording, I had 6 attempts to send it to the repeater, and so there was literally 6 tabs up here for the 6 attempts, and they still were not working. And I don't know what it was that was blocking everything, and I tried 5 duplications, and I tried 10 duplications, and it didn't really work. So this is the very first time that I actually tried just sending. In the first one, there were only 2 duplicates that I did, and a total of 3 tabs were actually sent. And these were how much? So this was for 95, and then ultimately the amount that was actually sent was just 195, or there was like a one completion that was made, which was the $90.25. And then the second attempt that I did, I literally sent these 20, and I sent the whole 190 that I could, and the final amount was the 180. And out of that, it seemed to be that so it was like 1263 was finally completed. So let me open up my calculator to see how many of them actually went through, because if the guy's balance was 100 to begin with, and so 1263.50 divided by 180.50 is 7. So 7 of the requests out of this 21 actually completed, and we were able to get it. There were multiple times where I went through here and it gave me a server crash, like it was an internal server error, and the server crashed and didn't work, right? There were multiple times that it gave me a success message, a 200 success message. So let me kind of zoom in on this for you just so you know what I'm talking about. This piece right here, there were multiple times that the server crashed and it gave me a 500 error, or a 500 response right here instead of the 200 that you see right here. It gave me a 500 response and it said server error, right? Internal server error. And there were multiple times that it gave me a 200 okay, but the money didn't transfer. So the only thing that I can think of that may have worked this time around, was the reason for it working this time around was that I started with a small amount, and then the second attempt was a really, really large amount. Like a number of duplicates is what I'm referring to. And finally, we got the flag. So this is out of the, probably by now I have done like over a dozen for sure, including last night's attempts and including all the attempts that I made prior to starting the recording tonight. I have made over a dozen attempts, and this is the only one that actually worked, and it actually caught me off guard because I didn't think it was even going to work. And now we have officially finished this room, and we are done with race conditions. This was honestly one of those things that I was like, dude, like I was this close to being like, you know what, F this, and I was just going to go and steal somebody's answer from the internet and make up some BS of what I did to actually make it work. But you just saw it live, and you should have seen the look of surprise on my face, because I was like, oh my God, I can't believe this actually worked. So it worked. We actually finally got the answer, and we have done a series of exercises on race conditions, and this is actually a really interesting vulnerability to exploit. And I have never used Burp Suite in this manner, so this is actually something that I'm very interested in learning more about, because I think this is a very strong skill set to be able to do this with Burp Suite. And I almost want to go and see what I can do in the real world in HackerOne or some other type of platform where I'm like, oh, I'm curious as to what would happen if we were able to pull this off in the real world. And this is in Junior PenTester, which is the other piece that's actually very interesting to me, because this is not an advanced, or it's not supposed to be an advanced strategy. It's supposed to be something that the junior pen tester or somebody who's studying junior pen tester is supposed to be able to pull off. But I have done this multiple times. I'm literally creating a playlist for CompTIA Pentest Plus, and I've actually done pen testing in a variety of different conditions, and they were much more difficult than this. It's just that this required so many more repetitions than anything else that I've ever done to be able to get that final flag. So I think the big lesson here is the persistence and the perseverance that is required to be able to pull exercises off sometimes. Like some exercises will actually require you to persist, like for real. You got to stick to it, and you got to try multiple attempts. You got to try a variety of different tactics or different versions of the same tactic, I guess you can say. And maybe it'll work or maybe it won't. And if it doesn't, you start back from the beginning, and then you keep trying until you get the flag, until you get the result that you're looking for. And that is a lesson of life. This feels like one of those things that it was very profound just to go through this, because it feels like a true lesson of life, not just pen testing and whatever. So anyways, hopefully you were able to pull this off. I don't want you to just steal the answer. I want you to try this as many times as it takes for you to be able to get that flag yourself. I think it's very important for you to get that experience under your belt and in your bones, in the cells of your body. I think that part of it is crucial. If you're just here to get the answers for the flags, I understand. I totally get it, because I was very frustrated and I almost did the same thing. But the feeling that I have right now is much more satisfying than having to go steal somebody else's answer for this flag. So I hope you also persist, and I hope you actually go through the exercise and you get to the flag yourself, and that way you'll be able to really walk away more confident than if you were to just steal the answer from me. But that's it. We're officially done with race conditions, thankfully. To get more videos like this one, and if you actually did find value in this video and from this channel, I really do encourage you to like, subscribe, and turn on that notification bell that's under this video so that you get notified the next time that a video comes out. As we go ahead and wrap up the junior pen tester, or at the very least, we're going to wrap up Introduction to Web Hacking, which has command injection and SQL injection. And then we're actually going to officially go into Burp Suite. For the people that have not seen the other videos on Burp Suite, we're going to go and do a deep dive of Burp Suite. So you'll really get a good training and good education on it. And I mean, drop a comment if you have any questions in this particular video, or really any questions about anything else that may be going on. If you just want to say hi, I welcome all the comments that come in. Unless you just want to be mean, and unless you want to say really not nice things, then don't leave a comment. You know, if my mom taught me, if you don't have anything nice to say, don't say it. So I'll say the same thing to you. I'm open to constructive criticism, but if you just want to be mean and if you just want to talk smack, it's like, I'd rather not hear it, and I'll probably just end up deleting your comment and blocking you from the channel, because I want to control my peace. I want to control my environment. But feel free to drop any questions you got. Feel free to drop any comments that you got. Feel free to check out the rest of the videos on the channel, the rest of the playlists on the channel. This is the one that we're building out right now. Every Friday, new videos from Pentest Plus drops. We've already finished Network Plus, so that's a complete playlist. Security Plus and Linux Plus are all complete playlists. People have gone through those playlists and have actually passed their examination, so I encourage it if it's something that you want to learn. There were very comprehensive trainings. The Python for Hackaholics Anonymous is reserved for our Hackaholics Anonymous members, which you'll learn about in just a few seconds. And these are also members-only videos and members-first videos that are available to Hackaholics Anonymous. So they get priority with all the posts that come in, and there are exclusive videos that are specific to Hackaholics Anonymous. So there's that. There's SOC Level 1, SOC Level 2, Security Engineering. There's the Cybersecurity 101. If you have not completed that, that's all really strong foundation in cybersecurity. And basically everything else that's on the channel. Feel free to sift and sort through the content to try to find anything that might be relevant to you. And apart from that, make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out on this channel. And I'm so happy that we were able to complete the race conditions video. So quick note from Hackaholics Anonymous, and we will be wrapped. If you're serious about your SysAdmin training and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackers, and at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video. Later.